Hello, welcome. This is a recording for lesson number 1 on counting. Okay, so the first topic here is the multiplication principle. Starting out with a few examples, if you roll a die twice, each time you roll the die, there are 6 possibilities. So the total number of possibilities for rolling twice will be the product, 6 times 6, which is 36. If we toss a coin first and then roll a die, we have 2 outcomes for the coin, heads, tails, 6 for the die. Multiplying those together, we get 12 possibilities. All right, here is a visual depiction of this process. So if we flip a coin, there are 2 outcomes, heads, tails, and then roll a die, we have 6 outcomes each. 4 heads followed by 6, and then also tails followed by 6. And so that leads to a total of 6 plus 6 equals 12 total possibilities. So the total number of outcomes is the product of the possible outcomes from each event. Two cards are drawn from a standard deck without replacement. There are 52 cards total in the standard deck. If we're not replacing after removing the first card, there will only be 51 cards remaining. And so the total number of outcomes would be 52 times 51, multiplying together for 2,652 possibilities. All right, another example here. How many 3-digit area codes are possible with repeats allowed? Now, there are certain restrictions here that would have to be subtracted in the real world. We can't start with 0. Things like 311, 911 are not possible area codes. But just to get a raw total here, we want 3 digits. Each entry could be anything from 0 to 9, leaving 10 options for each entry. Multiplying that together, we get 10 times 10 times 10, which is 10 to the third, or 1,000 possible area codes. So we're using the multiplication principle here. We're repeating this process 3 times, selecting a digit each time. There's 10 possibilities for each slot. 10 times 10 times 10 is 1,000 total possibilities. Slightly different approach here. You could think of this as all the possible values from 000 through to 999, which is 1,000 total. You have the numbers from 1 to 999 plus the 000. How many license plates are possible where the form is 3 letters followed by 4 digits with repeats allowed? So there are 26 possible letters, 10 possible digits. We're going to have 3 letters followed by 4 digits. So it's going to be 26 to the third times 10 to the fourth. 26 possibilities for the 3 lettered slots, 10 possibilities for each of the 4 digits. Multiply that all together. Many times in this course, we can leave answers in exponential form. We don't have to simplify. If repeats are not allowed, then the first entry has 26 possibilities. The second one, it's going to go down to 25 because a letter is removed, then 24. And then the same thing for the digits. We have 10 possible values for the first slot, and then 9, 8, and so on. So the final answer here is going to be the product 26 times 25 times 24 times 10 times 9 times 8 times 7. Again, in this case here, we can leave it in this expanded product form. So in this last situation here, where repeats were not allowed, but order does make a difference, switching the order results in a different outcome, we call that a permutation. Notation is NPR. From a total of n objects, we're selecting R of them. When repeats are not allowed and the order does not matter, then we have what's called a combination, denoted NCR. Now, these expressions involve a factorial, so let's define that here. This exclamation point here is read n factorial, and it means to multiply down starting at n and then decreasing by 1, n times n minus 1, n minus 2, and so on. So for our purposes here, we're going to be focused on restricting this to whole numbers. 0 factorial is defined to be 1. An example here of 5 factorial, that would be 5 times 4 times 3 times 2 times 1, which is 120. All right, so the definitions here for calculating NPR and NCR. So NPR, where n is the total number of objects and r is the number that you're actually using. Repeats not allowed, order does matter. It's n factorial divided by n minus r factorial, which simplifies down to n times n minus 1, n minus 2, to n minus r plus 1. Now, in a combination, order does not matter. So we have an extra term in the denominator. It's n factorial upstairs, downstairs, r factorial times n minus r factorial. Alternate notation for combination, we use this parentheses notation NR. Again, in the beginning of this course here, we may do a few of these out by hand, but a lot of times you can submit answers left in NPR, NCR notation, or you may also have access to calculators to simplify this stuff. So a summary here of the different possibilities when making our selections from n objects. So what happens is we have 4 cases here, whether or not we're allowed to repeat, and then whether or not the order matters. So if repeats are allowed and the order does matter, then we have n to the r, where you're just repeatedly multiplying n times itself. And so we saw that situation, repeats allowed, order matters. We saw that back up here with the area code situation. That was 10 to the third. Now, if order matters and repeats are not allowed, then we have an NPR permutation situation. And we saw that here with the license plate situation. We have, I'm sorry, it's 2B here when repeats were not allowed. We had 26, 25, 24, and then 10 times 9 times 8 times 7. So this could be viewed as 2 permutations here. So let's just fill that in. So we could express this in the following way. We could express this as 26p3 times 10p4. So again, when the order matters and repeats are not allowed, we have a permutation. Now we're going to skip over this repeats unordered. That's the most complicated one. We'll cover that in lesson 2. If repeats are not allowed and order does not matter, we have a combination NCR, and we have an example of that here. How many 12-person jury groups are possible from a total of 18 people? So if we're selecting a jury of 12 from a pool of 18 people, repeats would not be allowed. We cannot use the same person twice. And the order the people are selected does not matter as long as we have a total of 12. So this would be an example of a situation that is a combination. It would be 18C12, which is 18 factorial divided by 12 factorial times 18 minus 12 factorial, which is 6 factorial. Notice the cancellation here. We're comparing 18 factorial and 12 factorial. We're left with 18 down to 13, as well as the extra 6 factorial. But the 12 factorial does cancel out. And that leaves us with 18,564 possible combinations in this situation. Counting the number of words. How many words are possible using the letters Monday? Now, we're not talking about official words here, but just how many different ways that we can scramble these letters. So the order matters here, and repeats are not allowed. So this fits the format of a permutation. We have 6 objects, and we're going to use all 6 of them. So it ends up being 6p6, 6 times 5, 4, 3, 2, 1, which is the same as 6 factorial, which is 720. Now, what happens if there's a duplicate letter, if there's a repeated letter? So how many words are possible with the letters MEET? So since we cannot distinguish between the two E's, we're going to have less. We're going to have a smaller total here. If we had 4 distinct letters using the above, it would be 4 times 3 times 2 times 1. It would be 24. But because we can't distinguish between the two E's, we're going to have to divide out by that. We're going to divide out by 2, leaving 12 total possibilities here. So when we have a situation where there are duplicates, we have to divide by the repeated object. If all 4 letters were different, the total would have been 4 factorial, which is 24. But because of the duplicate there, repeated E, we divide out by technically 2 factorial, and that, which is just 2 times 1, 2, and we're left with 12 possibilities. So in general, when you're counting these permutations with duplicates, you have to divide for each duplicated letter. So for instance, in the word Mississippi, we have 11 total letters. We have the I appears 4 times, the S appears 4 times, and the P appears twice. So we're going to divide out by a factorial for each of those repeated duplicated letters. So the grand total would have been 11 factorial for 11 total letters. Then we divide out by each duplicated letter. We have a 4 factorial for the I, another 4 factorial for the S, and a 2 factorial for the duplicated P term. So that leaves us with 11 factorial upstairs in the numerator, downstairs 4 factorial times 4 factorial times 2 factorial. Final answer 34,650 possibilities here. Okay, that concludes the first lesson here on counting. In the next lesson, we will go through some more examples of this, some hints on some of the homework questions, and then move into lesson 2 proper. Once again, if you ever have any questions about the course or the material, please feel free to email me. Thank you.